Hey guys, welcome to another episode of the Math Guy. Today I'll be talking about concurrent points of triangles, which namely are centroid, circumcenter, orthocenter, incenter, excenter, etc. and I will be dealing with the relation between these points. So first up, centroid. So for a centroid, I'll be needing a triangle, that is this. So this is the triangle that I am going to use to describe centroid. So as you can see, I have named the vertices A, B and C and given them coordinates x1, y1, x2, y2 and x3, y3 respectively. Now the point centroid is the intersection, the medians of a triangle. Now what are medians? Medians are lines, or median is a line which joins a vertex, the midpoint of the opposite side. To represent it diagrammatically, this is what a median looks like. Now, as you can see, I have given names of the midpoints of the sides as D, E and F. And the line segment AD is a median, line segment BE is a median, the line segment CF is a median, and as you can see, these three lines intersect at a point G, and that point is the centroid. Now, as it is difficult to find out the centroid graphically every time, there is a formula which is coordinates of G is equal to x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. This is the general formula which we use to find out the coordinates for centroid. Now this concludes centroid. Next up, circumcenter. So in circumcenter, this is again the very basic triangle, and circumcenter, the term is pretty self-explanatory, as simply as it is the center of the circumcircle. So what is the circumcircle? Circumcircle is a lighter circle which circumscribes the triangle ABC. Just like the last diagram, I have named the vertices A, B, C and named the midpoints of the sides D, E and F. Now unlike the last centroid process, we do not draw medians. Here we draw perpendicular bisector of the sides, and the perpendicular bisector of the sides, the intersection of the perpendicular bisector of the sides is the circumcenter or the center of the circumcircle, which is denoted by this point S. This does not have any formula. This has to be found out by geometry. Now next is orthocenter. It is pretty similar. I'll discuss it just after this. Now orthocenter. Orthocenter is much simpler concept. It is just the perpendiculars drawn from a vertex to its opposite side, and the point of intersection of all these three perpendiculars is known as the orthocenter and is denoted by H. Let's move on, and next is incenter. Now incenter, again incenter is a very self-explanatory term. It is the center of the incircle. What is the incircle? Incircle is a circle which is inscribed in a triangle, which is the circle here, which is the lighter circle. I drew it with pencil, so it is lighter. Now as you can see, the incenter can be found out geometrically, but there is a way to find it out other than drawing the triangle and measuring the radius and doing all those things. You can simply take the angle bisectors of all the 3 vertex angles and then the angle bisectors, the point of intersection of the angle bisectors will give you the incenter. Now this has a formula so that we can find out the incenter easily, which is I is equal to, where I is the incenter, the coordinates of I are A x1 plus B x2 plus C x3 by A plus B plus C, comma AY1 plus BY2 plus CY3 divided by A plus B plus C. Now you might be wondering what A, B and C are. So I'll make it simple. Small a is the length of the side opposite to capital A. So length of side BC is small a. Similarly, length of side opposite to vertex B is small b. Length of side opposite to vertex C is small c. This was incenter. Next we move on to excenter. Now we have reached the final concurrent point, which is the excenters. Now these excenters are pretty interesting. And you will come to know why. Just follow me on this. Be with me. We extend AB line segment. Then we extend AC line segment. Now we get two new angles, this angle and this angle. Now the excenter point will be angle bisector of angle A, this line, and the intersection of angle bisector of angle A and angle bisector of these two angles, the new angles that we got, which will be around this point. Around this point. So this point will be known as IA. Why IA? Because A point is from where these two extensions are drawn. Now I would recommend finding out excenters using geometry, not using formula. As you can see, if we take B as stationary, there will be another excenter which will be IB. And again, if we take C as stationary, there will be another excenter which will be IC. Around here IC, around here IB, around here IA. And these are all angle bisectors. So there does exist a formula using which we can find the excenters, which is IA is equal to minus AX1 plus BX2 plus CX3 divided by minus A plus B plus C, comma similarly minus AY1 plus BY2 plus CY3 divided by minus A plus B plus C. You must be wondering what x1, y1, x2, y2, x3, y3 are. These are coordinates of the vertices. vertex A is x1, y1, vertex B is x2, y2, vertex C is x3, y3. Okay. Similarly, IB is equal to AX1 minus BX2 plus CX3 divided by A minus B plus C, AY1 minus BY2 plus CY3 divided by A minus B plus C. Again, IC is equal to AX1 plus BX2 minus CX3 divided by A plus B minus C, and AY1 plus BY2 plus minus CY3, mistake, divided by A plus B minus C. Oh no. Here, these are all the formulas. Sorry, that went a little under the resolution of the camera, the scope. So, next we come to the results that we can draw from these concurrent points. Now we arrive at the results. So, first and foremost, we have to know that orthocenter, circumcenter and centroid are collinear for any triangle, and they share a relation which is say this is the collinear line, this is the orthocenter, this is the centroid, this is the circumcenter, then this ratio will always be 2:1. Now, for an equilateral triangle, orthocenter, centroid, circumcenter and incenter are the same point. It is a special case, and this special case can be used to solve various number of problems. So, orthocenter, centroid, circumcenter, incenter are same for equilateral triangle. For a right angled triangle, say this is a right angled triangle. Let's name it A, B, C. The orthocenter is the point B. You need to remember this because this is very useful for various cases. So H is equal to B. And this was today's topic. I hope you like it. Next topic will be about straight lines, just the equations. So if you like this video, please leave a like, and if you want to see more from me, please hit the subscribe button. Thank you.